now, and I will start presenting my screen.
Yes, Sahas, I hope we introduced you to the team, right? Did we do that? Does anyone know Sahas?
Ganesh, can you come again?
So I don't know if you were introduced to the team. Does anyone hasn't been introduced?
Ganesh, your voice is breaking for me. Is it breaking for everyone else?
Yeah, yeah, we can't hear you.
Yeah, there's a lot of static.
Can you hear me now?
No.
I guess Ganesh, no, your only one mic is on, but it's very noisy.
Okay.
He said something about your introduction.
Oh, okay, okay, okay. So, I used to I'm working with kick drum since last uh, more than 2 years, 2.5 years now, and I have 4+ years of industry experience. I have interviewed a lot of you previously, and I guess we went over more detailed updates. But I kind of regard myself these days as a full stack developer. Previously, I was more inclined towards front end technologies like HTML, CSS, React, and all these things. But these days, I am doing a lot of AWS and backend related development and analysis also. So I've always tried keeping myself full stack so that I can contribute in more and more areas, and I'm not stuck with one uh, area of expertise, which I want to go to in the later stages of my career. But right now I'm open to a lot of different type of technologies and exploring all different types of fronts before locking myself into one domain. And with regards to the entire KDU experience, I used to lead the KDU efforts last year, so I know, I mean, how things go and how stressed you guys may be, and how excited and how much amount of learning you guys must be having these days. And so, I mean, just a quick message before I continue with my GitHubs and source code session is, don't get overwhelmed by these sessions. If you are, just see this as a learning opportunity which not everybody in your generation is getting, and do avail it to the most. So, if you have any questions, any personal questions, I'm sure Shishir might have some questions. He's from my hometown, and even after promising, I haven't met him yet. So, if you have any personal questions, if you want to, reach out to me for anything, I'm all ears. If you want to, like schedule one-on-one with me, I'm open for that too. Uh, there is some work going on at my house, so I cannot meet you, Shishir, at this point of time. But if you want, we can definitely meet online. So with that, if you guys have any questions or anything, we can take it at the end of the session. Okay. And welcome all of you to Kickdrum. It's a pleasure to have you all on board.
Thank you.
So yeah, so I am sure you guys must have started with a lot of code committing and a lot of GitHub related activities already. And uh, and what I'm going to do in today's session is just give you a brief introduction about what source code versioning is, why is it required, why sharing of code is very important in the current generation. So in the way we work. So and we'll do a lot of hands-on. I want this session to be as interactive, or as I mean, just try to take up whatever you can, whatever knowledge you can from me, and don't hesitate to ask any questions whenever you are in doubt. So what exactly is Git or any source code versioning system is? uh, it is a mechanism to track your changes, and not only your changes but track multiple people's changes in one area. And by that I mean that in your college days you must have been doing a lot of coding and a lot of you know updates to your codes, but you must not be uploading your code to any sort of any source of network for others to view that, other than whatever comparative coding you do. But in a collaborative environment like the industry that we are in right now, we need to share our code, we need to deploy our code, and we need to make sure that our code is accessible to multiple people in a distributed fashion. So by distributed fashion, I mean that it should not be on just one network. Even if I'm not on that network, that should be available to me if I have the correct credentials. So with all of these important requirements of having distributed access to codes of yourself as well as other people, uh, a source code versioning system was introduced called Git, and it helps people to maintain their code and the updates of their code in a distributed fashion, and not have it at one network or in their own local systems. And people can also coordinate with multiple developers, create branches in a repository, and work on separate branches if they are working on separate features. And and one more important system of any version control is we are able to track changes. So if there are any bugs that are introduced, if there is any bad code that is introduced, if there is any good code which you want to get inspiration from, we can always track who made the change, when the change was made, and all of these things. And we can also revert bad code at any time, or any unwanted code at any time. So that is also one important feature that versioning systems provide. And the last thing is we can have separate copies of our code locally versus remote, so that if we are making any changes and if we are testing the entire change, we don't affect other people's work, because it's always there in our local. Only when we push it, it becomes accessible to the entire group of developers. So so those are some of the features that a version control system has. uh, and Git also. There used to be version control systems like Subversion and stuff like that. That used to work on a single network. So there were bigger companies with a lot of more than 100 plus developers working on a project, and they used to maintain all of their code in single repositories over just one network, and it used to cause a lot of havoc with regards to accessing code, changing code, deploying code, since it had a lot of network related issues. So that is why Git came up with a distributed way of maintaining code with proper authentication and authorization in place. So uh, so another thing that I wanted to talk about is, so how do we work on a day-to-day basis on a versioning system. uh, so so I mean, whatever is mentioned over here is I've already covered it, and I'll also cover it in a hands-on that we will do just now. So I'll share all of these notes with you, so you can just go over and read it. Now I'll just walk you through some very initial basic commands uh, of the Git versioning system. And is there any doubt in this while that anybody has?
No
No.
doubt.
Okay, we'll just go over some basic commands before we start any sort of hands-on. And uh, so after these commands, I'll just go over some hands-on, and then if we have time, then we'll also do some bonus activities that are listed over here. I'll share all of this with you after the session. So now the first command is git init, which helps us initialize our repository, or essentially our code base. So that git init will initialize a code base, or it will associate a folder in your local machine with a git index. And by git index, I mean that that index will keep all the history and all the tracking details of what was committed when, and by whom and all these kind of details is maintained in an index. So whenever you do git init inside a folder, that essentially converts that folder into a git based tracking system, and that will also add a .git folder in that in that folder where you do git init. And after that, any change you make, any files you add, any commits you do, any pull that you make, any push that you do to the remote version of that repository, everything will be tracked on that index. So how to add files to that index is by doing a command called git add and then the file name. And instead of file name, you can give some regular expressions also, which you will see. But whenever you do git add, essentially that file will be tracked from then onwards. Whatever change you make on that file will be tracked. Again, I mean, who did it, when did he do that, or all these details. And if at any point of time you want to see what all change, which all files you have touched and changed on the repository, you can do git status, and that will help you uh, see all of the changes that you have made in a particular git repository. And git commit is going to commit whatever you have done onto that index. So once your changes are committed to the index, they will not be I mean, that is essentially a snapshot of that index, and only if you revert your changes will they go away from the index. Otherwise, they will always be available in the index. It's essentially taking a snapshot of whatever changes you did and putting it on the index. That is what git commit does. If you want to push whatever snapshot you have created to be available to other users in the who are using the same repository, then you can do a git push, and that will push it to the remote repository. If you want to pull other people's code into your own repository, then you can do a git pull. If you want to clone an entire repository into a new folder in your local, then you can do a git clone. And there are other commands like git checkout, which helps you check out a branch. And we'll do all of that when we go towards what are branches and how do we create new branches, merge branches, and all these things. So without any further ado, let's go into some hands-on session now. And before that, I just want to make sure that all of you have Git installed, and all of you configure your Git with this particular command. So what you have to do is just do. Uh, so I'll just show you as and when we are doing something. So I'm just going to work in uh, VS Code for now. You can open your terminal also if you want and start working there. So what we'll do is, first of all, we will, so everything that we will do now is going to happen on a local repository, and nothing is going to be on a remote repository. Once we see the basic commands and how to use them and all these things, then we will push our code to a remote repository. Okay, so right now I just have a blank slate in front of me, nothing, no project created, no folders created, nothing I have. I'm just going to start with so I'll create a new folder here. I'll cd into it. And so right now, if you see, there is, if I do ls minus latr, you'll see that there is nothing in this repository and no git folder, no versioning and no tracking is being done in this particular folder right now. So if I just do a git init inside this folder, so you can see that empty git repository was initialized in this particular location, and a .git folder was created. So if I do an lsltr, you see that there is a .git folder that was created inside this repository. So now let me open that particular repository. So now you can see that there is, other than the .git folder, there is nothing inside here. So let's create some basic files here. I'll just create an index.html, and I'll create a app.js. These are some random files. You don't have to worry about what code I write inside them. So now we have two files with us with some code in them. And now if we do a git status here, then we can see that we have two files in our git repositories, but both of them are untracked. We are not tracking them as part of this repository. Both of them are untracked. So to add them to be tracked, whatever changes we make to them, to make sure that they are tracked and accounted for, we can just do a git add and then the file name. So I can do a git add index.html, and if we do git status again, then we can see that index.html got added to our uh, whatever changes we make to index.html will now be tracked, but app.js is still an untracked file. So we can do the same with app.js also. Now, if it was not something that you were considering to commit, it was just a file that you were using to play around, then you can also just remove it from the git tracking by a command called git rm. Rm standing for remove, and if I just do a git rm cached and then app.js, and if I do a git status again, you'll see that only index.html is being tracked, but app.js was removed from the git repository altogether. So, so this is how the basic tracking of adding and removing a file in a git repository works in your local. Now we saw a git init. Okay. So we saw what git init did. It created a .git folder and started tracking file changes. We saw what git add did. We saw what git status did. Now let's see what git commit does. So I'll just add app.js back, and again as I told you, we can do some regular expressions also. So now I have removed both of these files, and if I want all the HTML files to be added in the tracking, then I can do a star.html. It will add all the HTML files, and if I do git add dot, then whatever changes you have made in any folders inside your git repository. So inside this git repository also you can create a lot of folders and such, and then any change you make in that folder, if you do a git add dot, will be added to the tracking of will be now tracked as part of your repository. So that if I do a git add dot and see the git status, then you'll see that both of these files are now being tracked. So with that being said, uh, let's try and commit our code. So so as you guys have committed codes previously, you must be using a -m flag for giving a message. So I'll just show you uh, both without. So I'll just show you how to commit your code without the message flag and with the message flag. So right now, let's say we want to commit. So I'll just remove my app.js, and I'll just commit my index HTML for now. So you'll be taken to this particular screen here where everything starting with the hash symbol will be a comment, and whatever you type as part of this screen will be your commit message. So first file, whatever message you want to give, you can give. Add index HTML, and you can just do a save, and you can see that the your changes was committed to the master branch. And if I do a git log, then you can see that uh, I with my with so the author of this commit was me, and the commit was made at this particular date. As part of the commit, this particular file was added. If the file would have been modified, then instead of add, you would have seen modified. If the file would have been deleted, you would have seen deleted. And you can see that the head is now pointing to whatever head of my repository is now pointing to the master branch, and this is the commit ID, which you can use at later point of time to you know share with other developers if you want some developers to only check out one particular commit, or if you want to track who did what and all these things. So you can do that with this commit ID, and you can also revert your commits using git revert. And if by chance you must have made a bad commit. So this is how so now your code is committed, and it's now uh, so now when I say your code is committed, essentially a snapshot is created in your in your git repository, which will have whatever changes you have done, and the only way to remove this change. Now if I go back to the index html, and if I make a change, and if I do a git status, then you'll see that my index HTML is now modified. Previously, it used to show it's added. The reason it shows modified is because the first uh, change that we made, where we were creating the file, is now committed to the repository. It's now being maintained in a snapshot, and now it is now tracked completely. The only thing now you have to do is now whatever changes you make in that file will now be considered as modified and not as a new file. So whatever change was made previously as part of the commit is now essentially stamped onto that branch, and and it is being tracked actively. So but all of these changes are only limited to your local repository, and nothing is pushed to the remote repository which you want to associate your local repository with. So just to show you quickly, uh, so now that we know how we can create a repository, how we can uh, add files, remove files, commit files, revert changes, and so these are, after these basic source code tracking things. Now let's see what exactly are branches and how exactly multiple people can work in a repository at the same time. So I'm just sharing a Jamboard with you guys. You can continue looking at my screen itself, but uh, um, so consider uh, every branch in your repository to be a pipe like this. And let's say this pipe refers to your master. And in Kickdrum and in a lot of other places, we generally keep our master branch to to always point to production related environment, and any feature related work, any bug fixes that we want to do, we first merge it on a branch called develop. And any quality assurance person, any QA would first check out the code from the develop branch, and manage and test that changes out. And then only if the QA person and the automated QA tests, if all of them pass, then only we promote whatever code we write on the develop branch to the master branch, and that is done as part of merging or rebasing, which we will look in some time. So let's consider we have two branches called master and develop, and we want to work on a feature called login. So what we will do is we will create another branch called login in our uh, in our local repository after we have checked out the develop. So first of all, we will check out the develop branch, and we will make sure that we do a git pull on it to make sure that we have the latest code. We'll see how to do git pull and all these things once we create a remote branch. But first of all, so what I'm telling you guys is the basic day-to-day branching strategy that we use in our client projects and our internal projects. So first of all, if you're given work on any sort of feature or uh, bugs, then the first thing that you should do is you should create a local branch, which uh, which you can name as the feature itself, or you can name it as the Jira ticket number, or you can name it as whatever change tracking mechanism that you're using, any sort of ticket number or the feature name. So So based on that, right now, since we do not have any sort of tracking, I've just mentioned my branch name to be login, and whatever work I'll do now on login, and uh, I'll commit that to the login branch itself, and then I'll push it to the login branch. But let's say if somebody else is also working on logout feature, and we want all of this code to be available at one single place, then what we need to do is, so let's say we have another branch called logout, and now what we need to do is, so I have completed my work on login feature, and Alok was working on the logout feature, so he has also completed his work on the logout feature. Now to test the login and logout things simultaneously, or essentially test these features with the other part of the application, which was the main meat of the application. So let's say we were working on any sort of e-commerce website which had the shopping page and everything already built in, but did not have the login and logout feature. So now that we have built the login and logout feature, and we want to test it with the main shopping page, which is already there on the develop branch, what we will do is we will do a merge to this develop branch. Now the way we do a merge is not so once you say that I've completed the work for it and now I want to merge, you cannot do direct merge on develop branch and master branch most of the times. So any developer will not have access to commit or merge to the developer master branch without a pull request. So what essentially a pull request means is, pull request means is that the source branch, which in our case is develop, is requesting the target branch, which is the login to sorry, the source branch, which is login, is requesting the uh, develop branch, which is the target branch, to pull whatever code it has. So that can be done as part of two different mechanisms. One of them is called merge, and one of them is called rebase. So the first one is called merge, the second one is called rebase. So merge and rebase. So what essentially merge means is, so when we merge login to develop, what happens is the develop branch now, so from this point in time, so let's say the develop branch, so this is the current timestamp, and the develop branch had n number of commits before this. So this was commit 1, 2, 3, and all these things. So in the history, if we see, it had 4 commits, and now this is the current timestamp. So what will happen is the develop branch will now start to point to the login uh, branch, and whatever commit it has, it will now, so the develop branch will move away from its path and now start pointing towards login branch. Now once the login branch is successfully tested on develop and we want to merge logout, then it will start pointing to the logout branch. So this is how the merge uh, of any branches work. And the way rebase works is, so when we start pointing from one branch to the other as part of merge, all of the history that was all of the commit history that was done as part of the source branch will remain preserved. So let's say as part of login I did 100 commits. My the amount of churn that I was causing to the branch was a lot, and all of that churn is now tracked as part of the develop branch, because the entire branch got merged into develop. So we will have the entire history of whatever churn it was there on the branch, and now the develop will point towards this. And so now once all these three branches are merged into develop, this is the path that develop will take. So uh, it will move in this particular path. But once we do a rebase, what essentially happens is, so when we do a rebase, what happens is whatever code is there in the login branch, that code will be pasted, like copy pasted into the develop branch, but the develop branch will continue moving in a linear direction only. It will not change its course and start pointing to a different branch altogether, but will continue working in the same direction. But whatever code is there on a branch, it will just get copy pasted. So only the copy paste part or the commit that causes the copy paste will be tracked. But let's say if there were 100 commits made on this branch, all of that commit will now be untracked, or that all of those commits will now vanish, because they were of no use for us. So let's say if you are correcting a typo, if you were making small constants, if you were adding some small things and you have added all of these commits into it, we don't need it on the develop branch. We want our develop branch to be clean and only show what high level things have been merged into it. So the high level thing is adding login feature. That is the commit message that will be done as part of copy pasting login to develop branch, but the develop branch will continue moving in this direction, in a linear direction, with just one commit message instead of 100 commit messages, which was the case in merge. And let's say and the same will happen with the logout branch. So now the question is, what branching or what merge mechanisms you should use. So the answer to that is, it depends on the project. It depends on what kind of people you're working with. So let's say if tracking each and every commit is important to the project. If you're working on a very big complex project with a lot of repositories, a lot of modules inside it, then you should use merge so that all of your history is tracked properly. But let's say if you're working on a very small project with which is a prototype as such, and you don't and you're only working in a team of 2 to 3 people, and you don't want each and every small commit to be tracked, then you can go for rebase, because rebasing will keep your main develop and master branches history look very clean. Whereas if you do merge, then the history will be the history will look like a tree structure rather than a linear structure. So just to show you what I am actually meaning by these two things. So this is one of the repositories and one of the projects that I do. Uh, and you can see that the develop branch, which is the black colored line, has a very linear history, and it only has the commits details instead of the branch details and everything. So you can see that only the commit which was made as part of the rebase is being mentioned over here, and not the entire branch information. But let's say if we were using merges, then for each merge, you can see that uh, so the information on this particular dot when I expanded was, the only information that it gave was that one branch was merged into the other branch, and there is no detail of what actually was merged. So looking at this message, I cannot understand what exactly was done as part of this merge. Like, was it a feature that was completed? Was it a bug that was fixed? So I cannot get a lot of information from this particular message. So I have to now go and so let's say this is the pull request is coming from branch number 155. So I now so the branch is kickdrum slash sonar cube. So now I have to go to the sonar cube branch, and now again have to check each and every commit. So now sonar cube branch is also having a commit from sonar cube test. So I have to come to the sonar cube test. That also has a merge from develop. So that becomes a hell in a way to track changes and understand what change was made by whom and when, and what was affected as part of the change. So that is why, if you ask me personally, I prefer this rebase based mechanism, so that each commit has a so that each commit to the develop or master branch, which is the main branch, which is the branch which has the most stable code, has only the commit details and not the branch details and merge details and all these details. So it maintains a clean linear history uh, of the branching that happened previously, whatever merges was made in the develop branch and master branch for that matter. We don't have a master branch for this project, so you don't see a master branch. So any questions? Any questions regarding branching? I'll show you how we create branches, how we merge branches, and all these things. But any questions on the general idea of how we do branching and why we do branching? Okay, so I'll take silence as no. So now the four basic commands that we require as part of understanding how to work with branches is, the first one is git checkout. That will help us check out a branch. So let's say if you are creating a branch, then you can do a git checkout with a -b flag that will create a branch. If you are checking out a already created branch in your local or from remote that you have already pulled in, then you can just give the name of the branch like this, name of the branch. And if you want to know which branch you're working on right now, then you can do a git branch. If you want to merge one branch into another, then you need to go to the target branch first by doing git check out the target branch, and then you can do the merge as source, git merge source branch. And with rebase, there is a different mechanism. So we generally do rebase with the -i flag, which means with -i, it opens the interactive uh, GUI for a lot of different things, like squashing a lot of commits into one commit, so that we don't have a commit hell to look into. Like dropping, if you want to drop n number of commits, but still want to keep whatever changes were made as part of that commit, but you want to drop a lot of commit messages because they were not important to the developer, like fixing constants, fixing typos, fixing this bug, fixing that bug as part of feature development. All of these things, we will get a beautiful GUI when we do a -i thing, and then the source branch name. So that is how we work with these four branches. So now let's see how we can do that in the branch that we created just now. So before that, what I will do is I will um, create a new remote repository where we will push this local repository that we have created. So the way we can do it is by going to github.com or Bitbucket or whichever uh, Git client that you're using. So all of these are Git client. They're under the underlying mechanism that enables version control inside all of this is Git itself. So we can just go to GitHub, do a new here. I don't want a templated repository, and I can just Git tutorial. And you can create a public repository or a private repository. So private repositories, you can control who can commit and who can view the changes, but in private, it's out there on the internet. Anybody can make changes, clone the repository, make changes, look at the changes and all this, update the repository. So I'm just going to create a public thing for now. So now you can see two things which I wanted to just talk briefly about. So the first one is a README file. So README file essentially is a markdown file which helps any new developer coming onto the repository to understand what exactly the code inside the repository does. So a basic description of whatever the repository is, responsible for, like uh, like in our case, it's just a sample repository, so you can just give this sort of a description there. And we can so generally there are two things which for which we use the readme file for. So the readme file will remain in the root path of your folder most of the times. So by root path I mean that the place where app.js and index.js html are also there, it should always be in the root of your Git repository. And we essentially use this README for two things. The first one is to just give a general idea about what this repository is all about. The second thing is all the details about how to check out your code, how to build your code, how to deploy your code, how to test your code. All of these general instructions you will see in the README file. So if I want to show you a sample README file, we'll create one for ourselves too, but this is a sample readme file, so it has the build status and all of the commands like how to start your repository, how to test your repository, how to build your code so that it can be deployed to so that it can be deployed to a website or AWS bucket or something like that. And what is the structure of the code. So so what I mean by that is how the folders are created, what files are there in which folders, and all of these. So that is the code structure. So all of this information you can keep in the readme.md. Md stands for markdown file, so that any new person who is getting onboarded on this to this repository will be able to learn how to make changes and test changes and deploy changes on this repository easily. Okay. And the other thing is dot git ignore. That means so there can be a lot of different types of files that we never want to be tracked, like for example log files, credentials, and a lot of different type of other files which we don't ever want to be tracked. One for redundancy purposes and the other one is for security purposes. So all of those file types we can store in a file called .git ignore. So what I mean by that is, so let's say I so let me create a dot git ignore file in our repository also. So I'll just touch this file. So we have this dot git ignore, and now what I'll do is any file name or any folder that you mention in this git ignore will not be even will not even be available for any sort of tracking. So what I mean by that is, um, so let's say if I don't want to track any txt files, which which may be created by any logger or any sort of you know error tracking, for that matter. Like let's say your website crashed and there was a log file that you created for that crashing. So you don't want to track that into your repository. So you don't want all the txt files to be tracked. So now if I go ahead and create a log.txt file in my root. Uh, so you can directly see in the VS Code itself that it has been grayed out. Uh, and what that means is if I do a git status, you'll see that only git ignore that I created is now being tracked, but the log.txt is not even tracked at all. Like even it's for untracked files or tracked files, it's not even considered for tracking. That's what it means. So that is how git ignore helps us. And license, we don't want to take any license. We will just go ahead with the MIT license. So I'll just do a create repository here. So I'm not adding a README and GitHub while I was creating the repository, so that I can show you how to do it in our local and then push it to the remote branch. So now our repository is created in the remote, and what we can see is some of the basic commands that we can do to make sure that this repository in remote is also replicated in our local systems. So git init we've already done. We'll create a readme file. We already know how to commit. We already know how to switch branches and all these things. So the next thing that we will do is we will associate our local repository that we created to a remote. So what I'll do is I'll say git remote add and then the origin. So origin means which is the origin essentially refers to the remote repository, and this is the link to that remote repository. So once I do this, I now so if I do a push, then all of my changes will be pushed to this particular remote repository. So the fact that we have this remote add command, the thing that it signifies is we can actually associate our local repositories that we have created to multiple remotes. So let's say you have you are working for for a project that can be made available for multiple tenants or multiple people can subscribe to that project. So let's say if you're working for an airline industry project and you want some if you want your code to be available for Indigo as well as Air India and Jet Airways and all these things, so you can but Jet Airways wants to maintain their code base in their own GitHub, and Indigo wants to maintain their code base in their own Bitbucket for that matter. So what they can do is, so what you can do, the actual source provider, what you can do is you can just add multiple origins to your local repository so that multiple tenants can subscribe to whatever changes you make and whatever changes you push, and so on and so forth. So right now we have just added one remote, and in most of the cases you might only have to work with a one-to-one mapping between a local and a remote. But this is just one thing to keep note of. So the origin essentially is a name that we have given to our remote. So anything that you want to push to this particular link will now be referred with this particular uh, you know uh, I mean, so this is the name for this particular remote. So if you wanted to, let's say, push something to Alok's Git tutorial, remote, then would have just given this name to be Alok's origin. And if we wanted to push anything to Drushya's, then Drushya's origin, and all this. So that's how we will be able to differentiate between multiple origins. So right now we're just working with one origin, and now I'll just show you how to push your changes. So now we see that we have already added your index HTML to the we already created a snapshot of the index HTML. We already have a commit that we can push. So what we can do is we can just say git push and then the name of the remote, which is origin, and then the branch that we want to push. So we can push multiple branches for that matter, but we just want to push the master branch for now. So what we will say is do a git push to this remote. The remote is origin, and then we want to say that push this particular branch. So the way we push is git push, then the name of the remote, and then space the name of the branch. So if I just do a git push, and so now one thing which we need to remember is uh, so when I committed, I was not asked for any sort of when I pushed the change, I was not asked for any sort of uh, you know credentials that if I'm actually able to push something to the remote or not. So that so the way we can actually configure that is, so first thing that we need to do is we need to configure a global email or the username actually. So for GitHub, the email itself is the username, So that is why we configure the username. And the next thing that would have happened if I were you who is using the git command line for the first time is, anytime you do a git push, I would have received a prompt saying enter your password. So essentially the password is the password for this particular GitHub GitHub client. So I have an account in this GitHub client with the username of Farhat Arvi. So whatever password I have, which I use to log in into this particular account, I need to use that same password for pushing changes to any repositories of this particular account. So now, how do you get this password? So I assume all of you are, all of you have enabled multi-factor authentication in GitHub and Slack and all of the other collaboration tools that we use. So if you have enabled um, multi-factor authentication, there are two ways that you can use to authenticate your local with your remote. The first one is, you can go to settings over here, and you can create personal access tokens for uh, which will essentially, if you have multi-factor enabled, then if you just enter your password, that will not work. You'll have to create access tokens to be able to authenticate between remote and local. So what you can do is you go to settings, go to developer settings, and go to this particular personal access tokens area, and you can create new tokens, and those tokens will act as your password. So if I just do a generate token, it will ask me for my actual password again, and that token you can give a lot of different permissions. Like, so right now I just want to, let's say, give a write permission, or I can just do a admin permission. And so right now, whatever permissions you want to configure, you can configure over here. And if I do a generate token, then if you do a generate token, then essentially you will receive a token like this, which you can use for creating, for pushing any changes to your local, from your local to the remote. And essentially this will act as your password anytime you want to do any sort of push or clones. So if you want to clone a remote repository into your local also, then also you will require a password. So for both of these workflows, for pushing a change and for uh, so I just deleted so that you guys don't misuse. So any change you want to make on your, so if you want to push from your local to the remote, or if you want to pull something from remote to your local, then you have to give this sort of a password. Now the problem with this approach is, every time you want to do a pull or clone or push, you have to give this password. So there is a better way of maintaining authentication is, and that is by using SSH keys. So what I did is, I created a SSH key in my local, and I associated that SSH key with my GitHub client. Now the way you can do, uh, you can create the SSH key and associate that with your GitHub client is given in this particular link over here. So I'll share this link with you guys, and you just have to follow these three simple steps. And the next thing that you need to do is, you just have to follow all these steps, and make sure once you have created the SSH key in your local, whether be it Mac machine or Windows machine or Linux machine, you have to add that SSH key into your GitHub account. And once you've added this key, you should see that key in your SSH keys tab in your settings. And once you have done that, you don't have to give passwords again and again. You just, whenever you do git push to the origin that you have specified, and if for that particular origin you already have a SSH key present in your local system, you won't be prompted for a password. So this is a private public key based authentication that GitHub will do on your behalf. So that is what I use for authenticating myself into the GitHub account of Kickdrum, as well as a lot of my other client projects that I work on. So that is how you can authenticate. So the reason I told all of this story is because when I did git push, you did not see any sort of password prompting from me. Any doubt?
Yeah, so like the SSH key you generate,
Mm-hmm.
and if you create any number of repository in with your account,
Yes,
so you don't need to specify username password every time.
every time. Yes,
Any repository which you create.
any repository, but the origin should be same. The origin should be logged in with the same user for which you have added the key for. So let's so
So,
I so what I mean by that is, mm, so I have currently logged in with this particular user. So
yeah.
GitHub has users and GitHub has accounts. So one single user can have access to multiple accounts. So right now, this Kickdrum is one GitHub account, and Sky Schedule is another GitHub account. And what I created for myself uh, was my own GitHub account. So what I mean by that is, so the repository that I created just now for the sample GitHub repository that I created just now, that is in my own account, and that account I have. So all of these accounts I have logged in with this particular user. So I have added the key for this user, and any account that has given access to this particular user, uh, I can be, I can add or make any changes to any repository in those accounts with this user of mine.
Okay.
Make sense?
I didn't know that they are separate users and separate account.
Yeah. So user is essentially, yeah. So user is different and account is different. So a single user can be subscribed to multiple accounts, and a single account can have multiple users, and so on and so forth.
So like if I'm right, you guys will be creating associating our account, we users to the Kickdrum account, right? In
Yes.
future.
Yes.
Okay, got it.
So I mean, what I think we will ask you guys to do is create separate users, which only will work for Kickdrum. And let's say you already have a GitHub user, and that you have already used for a lot of different projects and a lot of different GitHub accounts. So the way we would ask you to do is, we want you to create a different account or a different user, which will only work with the Kickdrum account in the entire KDU span, so that you have different credentials for your personal user and your Kickdrum user.
Okay, got it.
I mean, I don't have that sort of demarcation in my account. This is my personal account, and this is my personal user, and I use it for Kickdrum projects also. But this is a bad practice that I have not detached myself from yet. I will do it in the future, in the foreseeable future soon. So any doubts with regards to branching, with regards to authentication, with regards to the basic Git commands that we just saw?
I had a doubt.
Mhm.
So you said we don't push to like a master or a development, right? We raise a pull request.
Yes.
So initially, where do you push it to then? Like,
So
so
initially, when I showed you this example, I pushed it directly to the master branch.
correct.
So let me just go back to that repository. So in this repository, since I created this repository, I'm also an admin to this repository. So when I go to the settings, I can actually configure what branch action I want to take for what particular branch. So right now I just have this particular branch. If I add more branches to my repositories, I will have more branches here. And what essentially any branch admin, or oh, sorry, any repository admin would do is So let's say 5 developers are working on a repository, and one of them is administrator. So what he or she will do is he will just go ahead and add a rule that any branch starting with master, which essentially only the master will be, or you can give a regular expression also, will require pull requests before merging. If I select on this thing, then nobody, even the admin also will not be able to push to the developer master branch directly. They will have to first create a feature branch and then add their changes to that feature branch and then create a pull request. Somebody has to review that pull request. And so right now what I ticked was only pull request creation. We can also require reviews from the administrators or the code owners, so that only and only if a pull request is approved, then only the merge is eligible. Otherwise, if it's not approved, then also the merge will not be eligible to be conducted. And a lot of different tools we can configure here.
No, like, see, you push it to a branch and then you raise a pull request to the master branch, right?
Yes, yes.
So let's say you have your login branch in your local system.
Mm-hmm.
So where do you push it to on your client, like on the GitHub page? So like
I
you
push
only
it
have
to the
master.
I push it to so when I push, and so when I did say git push and then the origin, and then whatever I give here, that branch, if not present already in the remote, will automatically get created,
Okay.
or if it's already there, then it will be merged onto that branch, whatever change I'm pushing now.
Okay.
So let's say if I, so let's see an example of how we can do branching. If there's anybody has any other questions, let's see that. Then we will move on to how to create branches, how to create pull requests, how to merge, how to rebase, and all these things. Okay, so before that, I just wanted to show you some. So every time, if you want to, write this good push and origin and all these things, if you might see that as a boring thing to do, then you can create aliases in your bash rc files. And so the way I do things is, if I want to see which branch I am on, I just have a shortcut called gbr, and sourced. I see that I am on the master branch right now. If I want to see the status of whatever changes I have created, so I just write a command called gst, which is alias to git status, and I see whatever changes I have created. So I can pass on whatever aliases I have created to you guys as well, so that you can, so that your life becomes a tad bit easy. But the code you only have to write. I cannot help you there. So now we see that I was on the master branch, and I have at least 3 uncommitted changes which I don't want to push to the master branch directly, but I want to push to some other branch. So what I'm going to do is, I know I have the master branch, and then I'll pull the master branch first of all, so that I am confident that I have the latest changes on the master branch. So I need to just set my upstream first, and if I do a pull, then it will pull the master branch, and it says that already up to date. So whatever changes are there on my remote are the and whatever I have in my local, both of them are up to date and similar or same. So now what I can do is, I can just do a git checkout with -b, and for now I'll just give a feature based branch name called login, and now I'm inside the login branch. So now if I do a git branch, I see that I am on the login branch, and if I do a git status, I still see whatever changes I made are still untracked. So what I'll do now is, I'll add my index changes, my app.js changes, and my git ignore changes to be now tracked. So if I do a git status, you can see that I have a new file called gitignore, I have a new file called app.js, and I have a modified file which I can now commit. So previously we see that commit window. Now what we will do is we will just create uh, a commit message from the CLI itself. So adding login changes. So one thing that we generally follow is whenever you write commit messages, you should write them in a way that that first of all it should be uh, I mean in the most assertive way possible. So when you say adding login feature, it essentially means that you in the first person is talking, whereas when you say add login changes, it essentially gives a sense that when this branch, which is login, be merged to the main master branch, it will add my commit message related changes to that branch. So by that I mean that whenever login will be merged to master, uh, it will add login changes to the master branch. So that is how we write commit messages. A lot of people have a lot of different biased views on how to write commit messages, but this is my simple way of writing assertive commit messages. So I've committed these changes now, and I'll say git push origin login. So since there was no login branch already on the origin, a login branch will be created with this name. And what I see is it says that I can create a new pull request since the branch is already not there on the since this branch is not committed into the master branch. I can create a pull request. So when I click on this particular link, I have taken to a page where I can create the pull request. So what it says is when this pull request will be merged, the login branch will be merged to the master branch. So remember, it will be merged, it will not be rebased. Okay. So, so I can just do a create pull request over here. So that would have created a pull request with 3 file changes. The first one is the gitignore, the second one is the app.js, which we created, and the third one is the change that we did in the index.html. So anybody who wants to review it can review and drop comments, request some changes, or he or she can approve the change. And only so if I had created those webhooks that I was talking about previously to limit merges to master branch or develop branch, I would have seen this particular button to have been grayed out before an approval. So since I have not added those rules, this button is green for me, and I can just go ahead and do a git merge with my main user. And now I've deleted this branch. So whenever you're done with a feature branch, you can just delete this branch so that you have lesser, so the repository admin has lesser branches to work with. So now if you see that the commit history is I have added login changes from the login branch to the master branch. Okay. So this is how we create branches. Now let's say there was another. So I'm just going to make a quick change here. This is a small thing that I did on the login branch. Now I am going to git add index. So these are the kind of commit messages that you should not write, but I'm just doing it for demo purpose. And then git push origin login. So now I have pushed some change in my login branch. And let's assume that I am some other developer who is now going to start on the logout feature. So before creating that logout branch, what I should always do is go to your main master or main trunk branch, which can be master, develop, or whatever your code admin wants it to be. And first do a git pull, and so now you are on the latest trunk that your master code is working on, and you can see that the three files where the changes that we merged as part of the previous pull request are now being brought in your local also from the remote. So now your local master branch and your remote master branch are completely aligned with each other. So now what you can do is create another branch called logout and make some changes like, so in the app.js, if you add some more changes here, and if you do git status, you see that the app.js file was changed. But the problem now is, uh, if you want to make sure that your login feature works with your logout feature on which you're working on right now also works with the login changes, then how you can do is you can actually go ahead and merge your login branch inside your logout branch. So when you say git merge login, you can actually, so it will ask you what message you want to do as part of your merge. So all these 4 lines are just comments, but this is the actual commit message that is going to happen when your that will be shown when your login branch is merged into your logout branch. So that is how the merge works. So you can just so I'll just keep it like this only, and I'll save this. So now my login branch is merged with the logout branch, and you can see that the changes from login are also available on the logout branch. I'm on the logout branch, and login changes are also available here. Now let's see how rebase works. So any questions in this time, at this time? Okay.
I think we're good for that for now.
Okay. So the next thing, let me see if I'm running out of time. All of this I discussed, I think. I'll give you some reading materials and a cheat sheet, which so this is a git overview, and a lot in this git overview you'll see a lot of different complex commands also, like if you want to revert a particular commit from a particular branch, if you want to revert multiple commits, if you want to merge multiple branches, and all of these things. Git merge versus git rebase, we already saw what the changes are. Git merge is more elaborate but more messy. Git rebase is less elaborate but much cleaner. And SSS setup also, I just showed you why it is important, and how why it is better than asking putting a password every time. So I can also show you how to work with any IDE uh, for any sort of version control processes if you don't want to work with the command line. And then I can also point you to how to create free websites for yourself with GitHub IO. I think this I will give you a video and you guys can have a look if you are interested. This one we will cover before we, you know, end this session. So now a quick thing that we should do is have name about features. Okay, so now we made a change on the logout branch, and the developer on the login wants to make sure that his changes work with the log out changes also. So let's commit these changes on the logout branch. You don't have to essentially push, but the reason I'm pushing, because I'm doing everything in my local, I don't have to push, but the fact that I'm pushing is so that it gives a feeling that some other developer on a different machine is going to, rebase his local. So now let me go and check out my login branch. And what I need to do is I need to make sure that I have the latest changes on the logout branch also. I have the latest changes on the master because I did a git pull. I also want to make sure that, so now let's assume that the logout feature was complete and everything in the logout feature was pushed to the origin. So what we can actually do is let's merge our logout branch with master. Okay, so I'll just create a pull request and I'm going to merge this pull request. So what happened now is the logout feature was complete, the login feature is still in progress, and the logout feature is now merged to the master branch. So whomsoever is doing the changes in the login branch, first of all needs to make sure that he is working on the latest code. So what he or she needs to do is need to check out the master branch again. Now there is one more thing that we need to see over here is now the reason it's not checking out the master branches, it says that there are some local changes that you have made that can get overridden if you check out the master branch. So we know that the master branch does not have this particular line, right? So if I check out my code without committing this particular change, I might lose this change. So what I can do is before switching the branch, I can actually go ahead and do a commit, or I can also do a stash of my changes. And once I'm back on this branch, I can do a stash pop so that my stash changes are again popped into my current branch. So stash will stash your current uncommitted changes in a stack, a local stack in your local git stash pop will pop the stash or pop the from the stack in your local. So whatever you stashed, it will be brought back. So I'm just going to do a stash. So my change got, so you can see that my change got reverted, and it is now on this on the same uh, version or the same the change, the code is now on the same point in time when the branch was created or the last commit was made. So now I can do a git checkout of the master branch, and now you can see that I'm on the master branch. So now let me just pull the master branch because I just added something as part of the previous PR. So now the master branch is having the latest changes. Now I need to go back to my login branch, and I need to make sure that my login branch is in sync with my master branch. So what I will do is I will rebase it. So I'm rebasing my local login branch with the origin master branch. So you can see that in the rebase GUI, there are a lot of different commands that you can also work with. You can do a direct merge also. You can reset all your commits that you have done on this branch previously and reset it back to the point where the branch was created. You can label your branch head to some different label like uh, as part of login you are also doing sign up. So if you have done sign up changes, you can commit and name that head to sign up completed or something like that. Then you can drop a commit. You can I don't know what break does, I've never used it. And there are a lot of other features also. The one which I generally use is pick, which is to pick a commit, and squash, which essentially combines a lot of commits into one commit message, so that all the commits will be still preserved, the snapshots will be still preserved, but there will only be one commit message to keep the history clean. So there are a lot of different things that you can do with the rebase. So right now I'm just going to do save here because I'm not committed anything. but I am sure now that whatever changes I had in my master is now available in my login branch also. So now I can just do a git stash pop, and that brought back whatever changes I did as part of login previously to my local login branch, and I can just do a commit again. So now, if so, once you have done a rebase, you cannot directly push because essentially when you did a rebase, you actually copy pasted your branch into the master. So now if you want to push it again on the same branch, which essentially is non-existent, so you need to do a minus f flag, which essentially means force pushing. So what it means is, so if you directly do git push origin and login, it won't will give an error. So you need to do a minus f, and that should help you pushing your changes to the login branch too. So when I come back here, and let me go to the login branch. So I can create a pull request here. Mhm. Oh, I did not add my changes as part of the commit. Let's do this. I'll commit, I'll push. So the change was pushed and should automatically get picked up, but I'll just do a refresh. So you see that whatever changes I did previously are now added to this branch, and I'll just create a pull request from login to master with assuring the fact that login had the latest changes from logout also, and I did a merge, I did a delete, and now our master branch has the latest changes from all three pull requests into it. So that is how merge and rebase work. And if you want to see the history, so you can see that this particular line, why it's looking clumsy is because we did a merge instead of rebase, but otherwise the entire master history looks clean. So these two are merges that we did, but otherwise everything is very much linear in the commit history. So that is what I had to show. Now, when you use a lot of different IDs like VS Code and IntelliJ, you'll see you will generally see some sort of pre-installed plugins for version controls. So so let's me make some quick change here, and so whenever I made a change, and since it was already being tracked, so it got added in this particular tab, which is the source control tab in the VS Code. So from here you can directly do a plus like this. So when you do a plus, that essentially does a git add in the hindsight. Then you can just do a commit message change, and when you click on the tick option, it does a git commit with the message that you typed. And from the menu options, you can push, you can also pull that branch, you can do a lot of different stashes, you can discard changes and a lot of different things. So for now I'm just going to push it to the login branch again. So you can so you'll save a lot of time instead of uh, writing all of this in the command line. But I generally prefer using the command line only because it has a lot of different I mean a lot much more exhaustive feature list than what we have in the IDs. So even IntelliJ has the same version control based plugin which is pre-built. So you can just select files that you want to commit, and then you can commit files, you can push, and so on and so forth. So that is also something that if you want, you can use to enhance your productivity. Okay, I think I'm done. If there are any questions, do let me know. If not, I think we can break. So any feedback on this session? How was it? Was it too fast? Was it not too elaborate? Anything that you want to talk with me, irrespective of the Git session, also you can talk. We still have, we are running out of time, but we can, talk.
Hi, Farad. I just wanted to ask, will we